All right, so now we're moving on to the last section of this unit, and that is going to be solving rational equations. But before we go through this, I just want to go through a few things. If we give you a fraction and we say it's 2/3, this is actually a ratio. And we can consider this a ratio. It is a ratio. And whenever we have another ratio, let's say 4/6, whenever we set them equal to each other, they're called a proportion. And one of the ways that you can check to make sure that your ratios are actually equal is you can cross multiply. And 4 times 3 gives me 12. And then we can cross multiply here. 2 times 6 also gives me 12. And if these two numbers are equal to each other, then that tells us that it is a proportion and that these two ratios are equal. So what we're going to do first when we're solving these is we're going to be given two ratios that are equal to each other. So our first example is going to be 6/x is equal to 2/3. So we're given two ratios that are equal to each other. And as I showed you here, anytime that we have two ratios that are equal, we can cross multiply. You're multiplying your means and your extremes. You don't really need to know that, but you cross multiply and they're equal to each other. So that means if we want to solve for x here, we would cross multiply. Because we know that the means and the extremes are when we cross multiply that they equal to each other when two ratios are equal or when we have a proportion. So 2 times x is 2x, and 6 times 3 is 18. And then we can go ahead and we can divide each side by 2 to solve for our x. What you do to one side, you have to do to the other. So that's a common mistake I was seeing in your test, is people were adding one side but not the other. They weren't keeping their equation balanced. They were squaring one side but not the other. So remember, whatever you do when you're solving an equation to one side, you have to do to the other. And that means after we divide, x is then equal to 9. All right, now recall, we have to state our restrictions for our x. So since x is in our denominator, we need to say what value x cannot be. And since it's not being added or subtracted to anything, x just cannot equal to 0. Because if x were to equal to 0, we would have an undefined fraction. All right, there's just two more examples we're going to go through. All right, so for this one here, we have two ratios that once again are equal to each other. We have 5/x plus 2 is equal to 2/x minus 1. So you can do your restrictions in the beginning or the end. Let's just go ahead and do them first. So remember, our fractions, our denominators cannot be equal to 0. So x plus 2 is equal to 0. We would subtract over 2. So that means x is equal to -2 would make this equal to 0. So x cannot equal to -2. And then we can set the other one equal to 0. X minus 1 is equal to 0. So whatever value, we want to know what value would make this equal to 0. So we solve for x. So that means if x is equal to 1, it would make this denominator 0. So x cannot equal to 1. Right? So our restrictions are that x cannot equal to -2 or 1. All right? Now remember, whenever we have two ratios that are equal to each other, that means they're a proportion. And the way that we solve our proportions is we cross multiply. So we would do 2 times x plus 2. And then we would do 5 times x minus 1. So we know that when we cross multiply, since they're equal to each other, we know that we can cross multiply. So now we just go ahead and we're going to distribute in. Now it's important that you write the parentheses here because you have to remember that this 2 needs to be multiplied to everything. All right, don't just multiply to the x. This is then equal to 2x plus 4. So get into the habit whenever you have a binomial or two terms in your denominator or more that you write them step by step. Put the parentheses in and know that you have to distribute. And then we will go ahead and distribute this 5 in. So it will give me 5x minus 5. And now we solve for x. So we would isolate our x on one side. So I'm just going to move this 5x over to get our x all on one side. So it's -3x. And then that means I need to move my values to the other side. So I'm going to subtract the 4 to move it to the other side. -5 minus 4 is -9. Now to solve for x, we would divide each side by -3. And that means x is equal to 3. And since it's not part of any of our restrictions, we know that this answer works. It's not extraneous. And this is our solution. All right, so those are two of the questions that we went through really quick. When you have two ratios that are equal to each other or you have a proportion, you simply just cross multiply. There's one more example and I'm going to go through with you guys when it's a little bit different than this. All right, here you have 2/x plus 3/2 is equal to 19/10. All right, now when you have something like this, if you wanted to, you could just, because we've learned how to add rational expressions, we could just add these two together and then set up a proportion like we did in the other one where we'd cross multiply. That's perfectly fine if that's what you'd like to do. I'm going to show you a shortcut, something that it's important for you to be able to know how to do in the future. And most of you guys seem like you don't like working with fractions anyway. So let's go ahead and get rid of these fractions. Before we do that, let's just state our restrictions. So since x is all alone in our denominator, we just know x cannot equal to 0. Right now, if we wanted to, when we're solving this, we want to get rid of our fractions so we no longer have any fractions. What you do is you look at all of your denominators that you have. So we have 2, we have 10, and we have x. And we look for a least common multiple or a least common denominator between the three. So if we look at 2 and 10, the least common multiple that we have between 2 and 10, so we have 2, 4, 6, 8, and 10. And that means that 10 is the least common multiple between these two numbers. So we know 10 is our least common multiple, and we need to include our variable x. And what we do now is we multiply it to every term. So we take that our least common multiple, and we multiply it to every term. We don't multiply it over itself, we just multiply it to every single term. And since we're multiplying everything by the exact same value, 10x, 10x, and 10x, we're not changing the value of this at all. We're just manipulating it, we're rewriting it. And what this allows for us to do is it will allow for us to get rid of all of our fractions, because this x will cancel out with this x, and we're left with 2 times 10, or 20. This 2 can reduce this 10 to a 5, and we're left with 5x times 3, or 15x. And this 10 will cancel out with this 10, so we're left with 19x. All right, now these are the exact same equations, but written in two different ways. One of them doesn't have the fractions, so it's a little bit easier for you to solve that way. So we would just go ahead and subtract over a 15x. So we'd get 20 is equal to 4x. Divide each side by 4. That means that x is equal to 5. All right, like I said, if you don't want to do that way, you can always go ahead and combine these two and add these two fractions together to then get one fraction on the left-hand side of your equation, one fraction on the right-hand side, and cross multiply or get a proportion. It's your call. I do think this way is a little bit easier. It's more direct, and it's something that you will need to be able to do when we return back from winter break. You'll need to be able to do that because it's one of the ways that we use to solve complex fractions. All right, so that is it for this video, and that is it for this unit.